Hello everyone, welcome to our lesson. We're going to look at the angle in the semicircle. The angle subtended by the diameter at the circumference of a circle is what? It is 90 degrees. The angle subtended by the diameter at the circumference of a circle is 90 degrees. You know what the diameter does? The diameter divides a circle into two equal parts, right? You see that? So it divides the circle into two equal parts, into two semicircles. So that's why we're saying this is an angle in a semicircle because it is in a semicircle. Okay, right. So now and remember that we talked about an angle subtended by a chord at the center is equal to 2 times the angle subtended by the same chord at the circumference. So we're using that theorem here because this angle here is 180 degrees. And then so this angle, the C is going to be 90 degrees. Do you see that? So because the angle subtended at the center is 2 times, okay, or is twice the angle subtended at the circumference. Okay, right. Now let's apply that. Then what reason do we put? We say angle in the semicircle, or we say angle in half a circle, or we can say diameter subtends a right angle. So these are the reasons you can use. These are acceptable reasons. Okay, right. Now let's go to the question that we can try. Right. Before we do that, let's talk about the converse. The converse. So if an angle subtended by the chord, if if the angle subtended by the chord at the circumference of the circle is 90 degrees, then the chord is a diameter. You see that? Then the chord is a diameter. Let's say I have a circle here. I'll try to draw a neat one. Okay, almost. Yes, and then there's a chord. I don't know whether if this chord is diameter or not. Remember, a diameter is what? Is a special chord. And then if this angle here, let's name this angle. Let's say E, okay, D, let's go D, E, F. Now, if it happens that this angle F is 90 degrees, then what does that mean? It means DE is what? Is diameter. If the angle F there is 90 degrees, then DE is diameter. It means this chord passes through the center. You see that? That's what that means. That's the converse theorem, okay? Right. And then you can write the reason there. You say converse angle in the semicircle. You can write that as your reason, okay? Right, you say converse angle in semicircle. That's the reason for the converse theorem. Okay, let's go to the question. Given circle ABC, O is the center and OAC is 104 degrees, calculate the size of the angle. Right, okay, there are many alternative methods that you can have here, right? And then if you want to see alternative methods when it comes to a problem similar to this, you can go to our activity 4 on center theorems. You will see that we have but 3 approaches that you can use to solve this. But now on this lesson, I want us to concentrate on the angle in the semicircle, okay? Right, now let's try for 5 minutes, and then after 5 minutes, you check your solutions. Let's try. Right, welcome back. Did you manage to get something? What did you get for X? Right, let's do it together. So now, what information do we have here? We can see the line segments here. There's like line segment what? Right. Welcome back. What did you get? I really hope you managed to get the correct answers. Right, what do we have here? We have information like we say OA, OC and OB are equal. These 3 line segments are equal. So let's write about them. What can you say about these 3 line segments? Let me just pick my pen, then we write. Right, so it's OA is equals to OB is equal to OC. Why? Because radii. You see that? Because radii. Okay, right. And then now we can say that what do you have? If you check triangle OAB, this is triangle OAB. It's an isosceles triangle because OA is equals to OB. So it means these two angles, B1 and angle A, are equal. So we can write that angle A is equal to angle B1. Why? Because these are angles opposite, equal, sides, right? Okay, and then since OA is equals to OB, okay, we're referring to a triangle here. We're talking about triangle in triangle AOB, okay? Right, now, so angle A is equal to angle B1, so it means this angle A is also equal to X, isn't it? So angle B1 is X, angle A is X. So now we can say, if I check this angle A, then angle B1, and then angle O1, if we add them, they must give us 180 degrees because these are interior angles of a triangle. So we can say X plus 104 degrees is equals to 180 degrees, since is angle sum in triangle, right? And then we can say 2x is equal to 180 degrees minus 104 degrees, and then we get 2x is equals to 76 degrees. Then what is 76 divided by 2 here? What is 76 divided by 2? It is, you're going to get x is equals to 38 degrees. So it means x is equal to 38 degrees. Then that is 38 degrees then. Okay, right. And then we're done with the first part. We want to find y. I said we're going to concentrate on what? On the angle in the semicircle. Okay, let's not worry about the other alternative methods. You can check them in center theorems activity 4. Right, now our B1 is 38 degrees, but we can say that, we can say what? We can say angle B, or let me name it like this, angle ABC, the whole angle, this one, is 90 degrees. Let me show you. Okay, let me show you that angle there, angle AB, this one, you see, is 90 degrees. Why is this angle 90 degrees? Right, because it's angle in semicircle. Angle in semicircle. You see that? Right. So we can have that as our angle in semicircle. So it means that this angle is 90 degrees. And then we already have our x here. So we can solve for y, isn't it? Okay. We can solve for y. So it means x plus y must give us 90. So it means x plus y must give us 90 degrees. But x is 38. So 38 plus 38 degrees plus y is equal to 90. And then y is equals to 90 degrees minus 38. Then what do you get? Y is equals to 52 degrees. Done. So y is equal to 52 degrees, and then that angle is 90 degrees. Okay, the whole angle is 90 degrees. Okay, we found our y. Okay, right. I really hope you learned something from this lesson, and we're going to continue trying our best. Continue trying your best also on your side, and you continue what? Practicing mathematics. Mathematics is an interesting subject. Thank you very much. We're going to meet in our next lesson. Goodbye.